If you've looked at a tech job description recently, you've seen it. Developer, DevOps, tester, it doesn't matter. The word Kubernetes is everywhere. It's kind of become this mandatory skill. So, what's the big deal? Let's pull back the curtain and really demystify it together. We're going to jump right in and see what all the fuss is about.
To really get why Kubernetes is such a game changer, you have to feel the pain of what came before it. So, picture this. You're managing an application the old-fashioned way. You've got servers, things are running, but then traffic spikes. What happens? Some servers are totally overwhelmed, others are just sitting there doing nothing. And then a server crashes. Poof, your app is down. And updates? That's a whole adventure of manually stopping things, deploying the new code, and just praying you didn't miss a step. It's organized chaos, basically.
And that's where Kubernetes steps in. Think of it like a conductor for this wild orchestra of services you're trying to run. It's an orchestration platform, which is just a fancy way of saying it takes all those stressful, manual, error-prone tasks and just handles them. It brings a sense of calm and, more importantly, control to the whole system. So what are its superpowers? Well, for starters, it automates your deployments. You just tell it what to run and it takes care of the rest. And get this, it's self-healing. If a part of your application dies for some reason, Kubernetes sees that and spins up a new one, automatically. No more 3 a.m. wake-up calls. It also scales intelligently. When traffic goes through the roof, Kubernetes is smart enough to add more copies of your app to handle the load, and then it scales them right back down when things get quiet. And of course, it balances all that traffic so no single part of your app gets overwhelmed.
Okay, so how does it actually do all of this magic? Well, Kubernetes works by grouping computers together into something called a cluster. A cluster is really just a team of servers, and in this team, you've got two main roles. You've got the brains of the operation, and then you've got the brawn that does all the heavy lifting.
The brain is what we call the master node. You can really think of this as the air traffic control tower for your entire application fleet. It's watching everything, it's making all the big decisions, like where to run your code, and it keeps the whole system in check. The master node doesn't actually run your app, it just manages everything from on high. And if the master is the brain, then the worker nodes, well, they're the muscle. These are the workhorses. They are the actual servers where your applications live and breathe. They listen for orders from the master node, and then they get to work, doing all the grunt work of running your code. So if we peek inside that brain for a second, the master node itself has a few key parts. First, there's the API server, which is like the front desk receptionist. It's the only way to talk to the cluster. Then you've got the scheduler. It's the planner, figuring out the best worker node to place a new piece of your application on. The controller manager is the supervisor, always checking to make sure what's actually running matches what you want to be running. And finally, there's etcd. That's the memory. It's a super reliable database that stores the exact state of the entire cluster at all times.
All right, so we've got a cluster with a brain and some muscle. Awesome. But how do we actually get our app onto it? This is where you need to understand three absolutely fundamental building blocks: pods, deployments, and services.
First up, the pod. Now here's a really key thing to understand. Kubernetes doesn't run your containers directly. Those neat little packages of your code. Instead, it wraps them up in this thing called a pod. A pod is the smallest single unit that Kubernetes works with. Think of it like a little apartment for your container. It gives it a place to live, its own network address, and everything it needs. But here's the thing. You almost never create just a single pod by itself. Instead, you use a deployment. A deployment is basically a blueprint for your app. In it, you say something like, "Hey, Kubernetes, I want 3 identical copies, or replicas, of this pod running at all times." And it becomes the deployment's job to make that happen. If a pod dies, the deployment fires up a new one. It's also how you handle updates, rolling out new code smoothly with zero downtime.
Okay, but this brings up a really important question. If these pods are, temporary, they can be created and destroyed and moved around whenever, and each time they get a new network address, how in the world is anyone supposed to find your application? It sounds pretty unstable, right?
The answer, and it's a really elegant one, is a service. A service is like a stable, permanent mailing address for a group of your pods. It gets one single IP address that never, ever changes, and it knows how to find all the healthy pods that belong to it. So the rest of the world just talks to the service, and the service handles the messy business of routing traffic to whichever pod is ready to take it. It's brilliant.
All right, we've got the architecture, we've got the building blocks, but how do you, the human, actually tell this powerful cluster what you want it to do?
This is maybe my favorite part about Kubernetes. It works on what's called a declarative model.
This means you don't boss it around with a list of step-by-step commands, like do this, then do that. No. Instead, you simply declare the state you want to achieve. You basically show it a picture of the end result you want, and Kubernetes is smart enough to figure out all the steps to get there and to keep it there.
So the actual workflow becomes incredibly simple and powerful. Step 1. You describe your desired state, all your deployments, your services, the whole shebang, in a simple text file, usually in a format called YAML. Step 2. You hand that file to Kubernetes using a little command line tool called kubectl. And Step 3. You sit back, because Kubernetes takes over and does all the work to make reality match your file.
Now, deployments are fantastic for most normal applications, but the world isn't always that simple. What about more complex things, like a database that needs to remember its data? Well, the Kubernetes ecosystem has more specialized tools for those kinds of jobs.
So for example, there's something called a stateful set. It's kind of like a deployment, but it's built specifically for applications that need a stable, unique identity, like a database. And then there's a daemon set, which is cool because it makes sure that one copy of a certain pod is running on every single worker node in your cluster. This is perfect for things like log collectors that need to be everywhere at once.
And look, when your application starts getting really complex, made of many different parts, managing all those YAML files can become a headache. That's where a tool called Helm comes in and saves the day. Honestly, the best way to think of it is as an app store or a package manager for Kubernetes. It lets you install and manage even the most complicated applications with just a single command. And all of this, the self-healing, the scaling, the simple declarative model, it all explains why Kubernetes has become so dominant. It's not just for the giant tech companies anymore. It really has become the standard for running software reliably, and companies of all sizes are jumping on board to get these advantages. So, there you have it. We've gone from the total chaos of manual server management to the calm, automated control of a Kubernetes cluster. We've seen the brains and the brawn with master and worker nodes. We've seen how apps get a home in pods, managed by deployments, and made available to the world through services. So, the final question I want to leave you with is this. Now that you get the what and the why, how might this change the way you think about building and deploying your very next project?